we had already talked about how it's important to change management between summer and winter. But when you work on one barn and you watch it temporarily, this system is a lot more dynamic. Oh.
You're right.
It's a lot more dynamic. Okay, good. It's a lot more dynamic in when we talked about earlier how important it is to get a handle on the moisture, particularly, and watching the temperature. Within a week or two, it can change from good to bad, maybe even quicker if weather conditions are such. So I sort of emphasize with the single-page handout some of this dynamics, because what I'm going to base this discussion on primarily evolved out of visiting some 50 barns, and each barn is just a point. We caught it at a certain time during the year, or between stirrings, or between adding bedding, and weather events as they change as we looked at them. But looking at one barn and watching it temporarily, it changed my mind as to how dynamic they are. Again, looking at as a discussion and just reading this statement to you after what I said, success for the dairyman is based both on the management of the bed and the interaction of the bed and the surrounding managed environment within that structural envelope. And later, they're going to show Mike Ruger in discussing the envelope. And I think that's extremely important. I think after we saw all the barns out there, we found that you can hinder the ability to be successful by having a barn that just doesn't help you. This is what we learned. You know, we went out there and we measured these facilities, roof slopes, you know, all the dimensions of the barn. So all the barns that we have basically, we've created almost a blueprint for every one of them from measures. And we went out there and we measured temperature in the bed, just above the surface, velocity, and we chose about 9 different spots in a barn. The person there on the left is my Brazilian student who just finished his PhD down in Brazil. And the coldest weather he had ever experienced was a little warmer than this. On this day, this is the coldest day when he was here. It was down near 0. And as you notice, he is well insulated. We damn near killed him from the weather. After that day that we were out, he kept that clothing on in the truck that we were in, and we had the truck warm, and he was just back there still shivering. But by the time we were finished, he ended up his species adapted to Lexington area in Kentucky. We measured the moisture content. We measured primarily on all these barns at 8 inches deep, 4 inches deep, and near the surface. And I chose 8 inches because that's generally near the bottom of the tillage layer. And it's deep enough such that the ambient temperature and conditions near the surface weren't affecting it. So to get around measuring, 8 inches is the good depth to measure temperature to look at performance. Jeff showed this slide, but again, what was important on the barns and in the design is, again, what we learned with adjusting for, I adjusted for animal size because we had some farms that had Jerseys and smaller species, and production level. And we can see, again, with that bed, the majority of the barns still were not big enough on it, and that's important, you know, this area of per cow. And some of the slides later, it'll show them. The other thing too is, as the season changed, this is the outdoor temperature, and as the outdoor ambient temperature when we were at the barn, and this is the moisture level of the bedding in the barn. As you can see, as the season changed, we got higher moisture, which again is this emphasis on changing of the seasons. see, we got, a lot of the barns are getting up here above 65 to 70%, which is above what we should be managing them at. This dramatic, I had a line here, fall and winter. We had one of those dramatic fronts that moved through during the day, and it started out in the morning, I think it was about 70 degrees, and by the time we got back, it was in the 30s. And it stayed cold after that. So this line is pretty distinct for the time that we made the study. Now, one of the other parts of this is that all the beddings, we took a sample and we determined the water holding capacity, because this issue of some of the restrictions on NRCS and the standards in some water agencies were, well, what about groundwater protection? So all the particular beddings, on the average water holding capacity of the material was almost 73% on it as an average. And as you can see, even on our worst barns, we're not really getting up to that. We're near it, but we're not seeing near that water holding capacity. We're generally below it. And when beds were well managed, that moisture condition was well below the water holding capacity. So we're not seeing drainage, but we do see a gradient where it does get higher as we get deeper. Now this is a lot of scatter points on it, and just sort of looking at a general trend on bed moisture with time, bed temperature with time, and it did get cooler as we went into the winter. The different kind of beddings, green sawdust, kiln dried, or a mixture, we never saw a real difference in the bedding. But it all still gets back to management. Why can green sawdust work? If you understand the importance of moisture, you can make green sawdust work, because you got to use more of it. Sometimes we ran into the attitude that, well, it's kiln dried and green, well, we'll just put in the same amount. You have to get to the point where you have to understand that bedding is absorbing moisture, so you got to use more green sawdust. That's just an important point to get over. You buy drying potential. You buy dry matter in water, not cubic yards. A semi-truckload of shavings does not have as much dry matter as a semi-truckload of sawdust. And that's another point to get across to growers. Now this temperature on the beds, and these are all the ones in 8 inches deep was our highest temperature. It got, in some cases, up to almost 140 degrees Fahrenheit at 8 inches. And 4 inches is cooler. It's part of the gradient to the surface. But when we did surface temperature and ambient temperature in the barn, in the warmer weather, the surface was cooler than ambient. This is what's occurring is evaporative cooling. As air is moving over the bed, it's cooling it. But as we get into winter, the bed temperature is higher than ambient. There's a few degrees, maybe 4 to 5, but there is a distinct difference in trend, and that's again a seasonal issue. So evaporative cooling, 3, 4, 5 degrees Fahrenheit of that surface temperature. That's the reason why I said earlier when I was sitting on the bed, and I didn't get a hot seat, you get a bit of insulation from that hot temperature that's occurring there. In the barn that I'm watching about every 2 weeks, the same kind of trend occurred. This is the, I got to look at it again, bed surface temperature and ambient. There it's warmer. As we got into the warmer weather of the summer, the ambient was higher than the surface temperature. The temperature at 8 inches is higher. This is at the point where we were working with him to get the bed working better. And you can see at this point, it was cooler. Let's see, 8 in. That's the moisture content. There's the moisture content. We were having some of the trouble getting it started, and as we got the moisture content down to lower moisture, this bed started working well. Okay, all the barns that we visited. We heard earlier about the optimum temperature from Dr. Keener talking about 45 to 55. This is the curve of temperature at 8 inches deep. And as in this line, you can see that it's about, from what we saw in terms of moisture content, that's where we got about the maximum temperature of the beds that we were measuring. For composting, 40 to 60 is what we usually recommend. That could be a management range that we're looking at, but the optimum still is around 45 to 55. And that's, as we've seen, that's a repetitive, and this is what we found in the field. How does the stocking density affect the moisture content? This is the winter data. As we get, obviously, less density or more square footage per cow, we're seeing lower moisture. And that's what we saw with the barns. And we see it again in that warmer weather in the fall, the same trend line. Less cows, more square foot per cow, we end up getting a lower moisture. Now, the other thing is visually going out to a barn, just by looking at the barn after they've, let's say, tilled it, or even many hours afterwards, just by looking at what the surface looked like, I can give you an approximation of moisture. And this is based on just particle sizes. When we start getting into more and more of that bed is greater than 1 inch in diameter, we see that the moisture is higher. That's just because the tillage creates those chunks and they aren't broken up. But as you get drier moisture contents, the particles are smaller. And inside these diamonds, these are our rototiller. This is where the rototiller was used. And we're getting smaller particles. The thing is if you just think of drying, if you've got a large chunk that's wet, it takes a lot more time to dry that out. So if you get smaller particles, you're getting a better drying. So again, this is the advantage of the rototiller also. Smaller particles, better drying. Another thing that we saw too is what's the carbon to nitrogen ratio. We had heard that commented on earlier with composting. And as the moisture content went up, the carbon to nitrogen ratio also went up. In other words, we're losing a lot of nitrogen as we're getting into that higher moisture. We're losing a lot. Even though if we manage to put on bedding, which is high in carbon, you would expect sort of, well, that's what would occur, but it's just the opposite. We're losing a lot of nitrogen as we're getting a higher moisture. That nitrogen is valuable to you. So again, besides the aspect of the bed, here's the other economic advantage of trying to keep it drier. Again, with the barn that I'm watching pretty much every other week, we can see this bed depth shrink with time if it's working. If you go back to the previous slide when I said the compost was beginning to work well, one part of the barn he didn't clean out, which is this end of the barn, and when I first started measuring it, it was getting up close to 2.5 feet. But as that compost was working, even though he was adding some bedding to it, the depth changed by about 1 foot. Because when the composting is working, you're degrading that material and you're shrinking, which is typical of composting. These other ones were steadier, but they were shallower. And now the trend over time on nutrients. He was pretty steady, but just last week he was starting to get higher in moisture. He started adding more cattle than it was designed for. It was designed for about 120 cows, and he was up to 135 on it. This issue, again, for his timing of his herd is in the winter time. He was higher in numbers in the winter. This is the riskier time of the year in terms of these beds. So this key issue of designing for what your winter population is important. And as he added more cattle, you can see that the nitrogen content was going up. The C to N ratio is going down, which is what you would expect on it. Trying to encourage him to add more bedding because bedding costs money is I think that if he doesn't get on top of this, he could run into this problem that this bed will get out of hand and he may have more problems going into the winter. So it's constantly, I keep telling you, you got to get more bedding. Spend a little bit more now because it'll save you money in the long run. I think this is important of getting ahead of the issue. He's heading in the direction right now where he could have a problem. It's all just based on the moisture. Again, I'm going to reemphasize this stirring, twice a day religiously. I'm not going to stop saying it. And even 3 times a day if you have a chance where the cattle aren't on the bed. Some people are sometimes taking them off to feed them and the bed is open. Spend that extra 15 minutes because it helps increase in drying on it. In Kentucky, most of the tillage is with a cultivator, but we're emphasizing that rototiller, is what we saw earlier. I think the optimum is both of them. Deep tillage to try and, again, get some more of this material, get air down to it, but the rototill gives smaller particles, it dries better. This issue in the wintertime on getting bedding and reducing your bedding, if you have good weather and it fits in with your management, let them out on pasture. It does reduce the moisture if the weather is good, if that fits in with what your goals are. Increase air circulation in the barn when the cows are out. I don't want to see it when they're there because of the chilling effect on it, but not to the point where you lose too much bed temperature. Again, the winter time is key. You don't want to manage it to try and get the water out, but you'll lose the temperature in the bed. Again, if you got a thermometer, use it. Use kiln-dried sawdust in the winter, green sawdust during the warmer weather. In Kentucky, green sawdust is available all the time, but it doesn't hold as much water. But in the summertime, we got good drying rates. So use the green in the summer, and if you can stockpile or have a structure to hold kiln dried, buy it in the summer. We find it's cheaper in the summer in Lexington, in the Kentucky area. So this is one strategy. When you work the numbers, you can see that potentially you can pay for that barn that you hold it in, particularly if you can get a good price in the summertime. Okay, that's what I said, stockpile it. Why don't packs work? Stocking density, just as I'm seeing right now with it. Too many cows, sometimes poor distribution because of the barn. You get some blockages of air in some parts of the barn due to wall. Cows don't like it under heat stress conditions. That part's dry, but the other part's wet. Bed material used, Jeff talked about it. Straw. He says, we said straw is bad for a bit. I think straw can still work. I know Jeff doesn't like hearing me say it because it is risky if somebody chooses that as a strategy. But I think what may work, and what we've seen anecdotally, is straw that's ground. You shatter the cane and you open it up that the pores can suck in the water better. And I think something that is on a chopper that has a screen of 1 inch or 3/4 of an inch would be what you want to do. I think the optimum is mixing it with sawdust. Insufficient bedding volumes. It's that, as Jeff told me, he says, to save a penny, they risk losing a dime. Or save a dime and whatever, I can't think of it. Inadequate and ineffective stirring. Again, not deep enough, not well enough going over it, or if you get a big chunks, it's not going to dry out. Again, stirring frequency, not less than 2 times a day. I would like to see to get down to 10 to 12 inches, even if you have a rototiller, which won't get down there, but use it with a tillage tool. And again, if the tractor is too big, you can get compaction, but what I've seen is people with a front end loader putting tines on the front end and pushing them through, and their tire tracks compacted, if you measure the temperature about an hour after they do it, it's cold in the wheel tracks because there's no volume to hold oxygen. Starting the pack in late fall and winter. It's just that we see people struggle unless they want to pay a lot of money for bedding at the beginning. It's just better to start when it's warmer. Or, as I was saying here, one of the growers was saying, taking it out in the springtime. How does that work into your cropping system? Too much ventilation in the winter. That's the reason why we think curtains are important, particularly when there was no curtains. One barn worked real well, had no curtains, but he had another structure next to it on the windward side, which blocked the wind. So, I mean, it occurred, but it's not the most ideal for warm weather ventilation. And a lot of barn design flaws. What we learned from the potential structural design flaws, and I don't know what Mike will say, and I may change this slide after I listen to his presentation. I think one of the interesting things here of listening to each other from the different states is how much more I've learned from other people's knowledge, and this just makes it interesting from why the three of us had gotten, or 3 states had gotten together for this workshop. Not enough space per cow. Inadequate ventilation. Sidewalls were too low, too close to other buildings, too small of a ridge opening for the diameter.
When you talk about the sidewalls being too low, are you talking at the eave 16 foot or
Eave,
12 foot of space between the wall and the eave?
The eave and the wall size, you know, the 4-foot wall and the eave. You need at least, I think if you go down, and you could get away with 14 foot to have enough air movement, open space.
14 foot of open space.
Between the wall and the eave.
So you're talking 18 foot to
Yeah.
the eave.
You got to have, with this extra moisture and heat that's generated from the bed, you need more air volume into the barn in the hot weather. You know, that's a key thing, and particularly when you get real wide barns. That's a, you know, I think we've had some barns 120 foot in width, and that becomes extremely important. Too small a ridge opening, poor ridge opening design. I know we see a lot of and I'll talk about a lot of monitor roofs or half monitors. Particularly in the summertime, they're facing our dominant wind direction, and even under some calm winds, it's enough to block that hot air and moisture getting out if they're facing the right direction. And in the wintertime, they act as a nice scoop for cold air and just blows right down onto the cows. Fan availability and placement. Jeff talked about how the cows know where the wind's blowing. And it seems like this spacing that we found on a lot of the barns on the fans, by the time you get these box or panel fans, when it gets down to the floor level or the cow level, they're not accounting for the dead space. They're spacing them based on freestalls. Eave overhangs and curtains, building orientation, walls along the pack that block. Still, it surprised me, and Jeff knows more about with the freestalls and other facilities. Again, just not close enough to feed for animals just to walk and then go back and relax. Not enough water space, cow flow and traffic bottlenecks, waters and pack, concrete base. I know it was a question that was asked whether it's concrete or clay. The issue, and the questions that I've gotten in the past about it is groundwater contamination issue. And I don't think it is much of an issue as some people ask the question about, because they think that it becomes a tub. There's a tub of water under there, and if you're managing it properly, it should not occur. This is the ventilation systems that we had. Box fans were the predominant. High volume, or we call them the big ass fans because they're made in Lexington. So, but they're HVLS for generic terms, fans, about a quarter of them. These are highly inefficient, and they just do a better job in air distribution through a barn. Even though I've observed with these big fans, even though sometimes if you have, it needs the minimum air velocity at the cow level, if the fan next to them is a little bit higher speed, they'll still move to the other fan. These are just some of the ones with the high volume, low speed. And some of our ridge designs, the overshot half monitor roof is a predominant. It seems to be neighbor to neighbor or peer-to-peer advice on it. You know, we'd rather see this kind of a design to get better all around weather conditions for it. But again, it's us recognizing how this is communicating and working to try and get proper design out there. We did a study on a wind tunnel on a model of our compost barn. This is our Brazilian student who built this model barn to do studies on it. And there's that half monitor roof, and where it just captures that air. In the wintertime, it be cold. In the summertime, blowing the opposite direction, it'll pull air out and get better ventilation. But again, sometimes it's the winter issues. Here's the issue with air pattern onto the barn, onto the bed. If we, let me get these all up here. I didn't correct it too well. But the patterns will change depending on that ridge design, on how that air gets down onto the bed and can cool it. And as we said, it's important on temperature loss of that bed as to how well we can maintain it. And the ridge has a lot to do with certain areas of it being colder than others. I didn't correct all these. Okay. The other thing was position in the landscape. This particular barn was built, cut into a hillside. They built it in dry weather, but when it got wet, there was a spring underneath. And he had a wet spot here, and to overcome it, it's going in there and doing some kind of drainage tile. This barn was built on a ridge top, good design. This barn was built down in a bowl, you know, stagnant air around it. But the thing is, this is the barn that hasn't emptied the stall for over 2 years on the or the bedding, so it's working well. I didn't expect it to, but it did. That's just what Jeff had said. Okay, managing that bed, we got to generate heat, and it comes from bed stirring, bedding type. You know, bedding maybe particle size. Again, it's the rototiller. This is the case where we can see that the tracks of the front end loader here, and when you, as I said, if you measure that temperature, it's colder in the track. Moisture levels, again, too high moisture, dirty cows. Here's the predominant differences in bedding types: sawdust, mixture, shavings. Problem with shavings is when you create that shaving, you put a mill finish on it, and you'll seal the pores, so it doesn't absorb water as well. Wood chips, no. Again, you don't have much surface area per volume. Hammer milled wood, like toothpicks, if they can get into that animal's hoof, it can cause some problems with hoof soreness. Let's see, some other alternatives. Ground corn cobs have worked. Soybean straw stubble work. Canaf maybe. We've seen some of these ideas on people using them, but again, wood shavings and sawdust seem to be predominant. And some success with a mixture. This is one of the anecdotal evidences. They said ground straw works well, and this was up in cold country. I think it was in South Dakota. Okay.